Hello again. This is gonna be dirty. You wanna see dirty? I'll show you dirty. Let's make a dirty video. Well, that's dirty. Yeah, plenty dirty. What is it? An old piece of test gear known as the Sencore. We can adjust a little bit. Focus. And focused. Alright. The Sencore LC-53 Capacitance meter. And right now, it's not very healthy. So here's what it does when it's plugged in to nothing. And even the probes are not feeling very good. But I think we have another set of probes around here. But yeah, this is not good. It's jumpy when you press the value. Of course, there's nothing in there, so you're not supposed to really be doing that. But this is supposed to flash when you turn it over into the high voltage area. Or maybe this needs to be on leakage. No, doesn't seem to. That's not responding either. This is supposed to be flashing. So, has seen better days, that's for sure. Okay, so let's see if we can pull this apart. Look at all the dirt. Holy shit. It's like I haven't used it in 10 years. Which is basically the case. Oh. Good Lord. Here we go. Ah. It's a rear entry. There we go. Slide this up and off, and ooh, look at that. All right. Put the top off to the side there. Let's take a look at this here. Ooh. Let's take the air gun to it. How about that? Many years of dust and filth. Holy shit. What a bugger. What is this? What is this crazy little bodge? That looks like something that I would have done. Although, no, it's got, no, that could be original. Maybe. Who knows? I don't ever recall being in here. I don't think I've ever torn on into this here critter, so probably not me. Alright, so after doing a little private poking around myself, didn't want to get you too involved into the whole process because it's a little tedious of just staring at the components, looking to see if anything visually is bad, and I did find something. So let's take you on this journey here. See if we can't zoom in. And I don't know if you can spot it. Have you spotted it yet? Should at this point. here we go. Look at this resistor. That is not a healthy looking resistor, is it? Alright, so here's part of the selector switch. It's goes up there, and but here's right off of the mains transformer, right? And if you look here, O in this case stands for orange. It's a 35 volts AC, and comes up here, and look at that, 100 ohm resistor and a diode. Why is it all burned up? Could it just be that it got too much use? Or maybe I was leaning hard on a capacitor with some voltage applied to it, and it just gave up the ghost, all the magic smoke. So I'm pretty sure the markings I can make out on it, there's definitely brown and black in there. And on a 100 ohm resistor, well, let's take a look. Yeah, bigger better. If it blows up, we know we got something serious going on. This will handle any extra current that may be getting thrown on the meter. So I'm just going to take our handy needle nose to the nut, loosen her up. There should be a washer in here too. That'll come falling off. Let's see, can we get this out of here in one piece? That would be a wonderful idea, but the odds of that happening are, well, not looking too good. What is holding all this together? Okay, so let's see. Maybe we can unsolder the leads, as long as we don't forget where they go. But we get it on video, so not going to stress it too much. This little red fella here. Boy, it wants to melt. Let's try not to break it. How about we do something safer? I don't care about the wire so much, but I do care about breaking off that tab. That would be a bummer, to say the least. And it's free. So, okay. And of course, there's other things holding it in. There's a yellow wire over here going to this little connector on the PC board, so that's off. Okay. This is looking better. So if we can rotate around and get it to rest and maybe not be so bright, perhaps. There's always a chance it's shorted out. So we're going to get the meter on it. And 0.576 forward voltage drop, so That's actually reading good. Well, that's a good sign. What else have we got here? Is that another diode? Seems to be. 0.548 on that one. So there's a diode going like that, and then like that. So, okay. So we can just put in a beefier resistor like this, and maybe it'll come to life magically. Probably just better if I snip it out. I'm just gonna bodge in this bad boy. Do a little wrap right there with the wire. That's fine. And of course, you're missing all the action because I'm not paying attention to my camera. Oh boy, tragic. So, so here's the end of the resistor I'm going to put in. Just let it melt in there good. And make sure it's on there. Okay. It's on there. And we need to go to the side of that diode. So I'll take a look. Let's get that in there. All right. Slap some solder on this. So I'm not really going for neatness too much. I just want it in the circuit. These things are hanging components off of a rotary switch like this. That's a bit of a bodge to begin with. The whole idea of it. Okay, we'll snip this off. Good thing I'm wearing my safety glasses because that thing just bounced off of my lens. Just saved my eyeball. Okay, so let's snip this lead off. Okay. Alright, so I don't see any other components in here. Just a bunch of wires. So let's make sure they're not shorted against anything. Some jumper wires they got in there. Alright, let's put this back in. And we need to, okay. So, what say we fire this thing up? Kind of hard to see. Yeah, I'm still getting a negative with nothing connected to it. Let's try hooking it up to something. This old cap connected and 12.7. Let's get a higher value capacitor in here, see what it comes out to. Like 330. What do we got here? Yeah, 330 mics. Okay, so here's our hot lead, here's our negative. 330 mics it's supposed to be. And actually, let's see if the zero out control is still not having an effect. So let's go for value. 351. Okay. That's almost acceptable. Let's try the leakage test. This cap is only 25 volts, so set that scale to 25 and see. The leakage is 0. I wish I had a cap that actually had some leakage to it. So now, okay, so seems as to how I forgot to reconnect the LED. Let's see if we can't do that now. Focus. Focus. Close enough. So we have to get this red wire here and the black one right down below over there. Solder onto the edge of these wires here. We'll pre-solder. There. Okay, that's connected to that. And this is done. So, yeah, that's fine. Solid enough. It's an LED. It doesn't draw very much current, so there's no need to go crazy over it. Alright, so let's move this around. See if we can get our LED into view here. Okay, so here it's the LED that's supposed to flash. Irregardless of whether or not you have a cap attached or not, doesn't matter. As soon as you turn the dial, it should flash. So let's see what happens. Find the power cord. Alright. And it's on. Let's turn the dial to a flashy position. And nothing. Shit. Interesting. The indicator's flashing. Really shouldn't, ought to be. Disconnect the cap. Yeah. So that's not supposed to be flashing. That's supposed to be flashing. Or maybe this is supposed to be flashing. I don't quite remember. Now I'm at 400. It's not flashing. At 500, it's kind of going through some crazy shit. But yeah, it's certainly that's supposed to be flashing, not the display. At least I'm pretty sure not the display. Well, this obviously has more problems than I was hoping for. So, seeing as to how this is all very mechanical in nature, I'm going to try cleaning all these little wafers. I have this stuff, PF Precision Cleaner, so we'll give it a shot and see what happens. See if we can find an area to actually get this stuff into. There's actually, oh, look at that. There's a hole in there that actually was a perfect fit for the nozzle. And here's another one over here. Get in a position I can get the nozzle into. Kind of blasted right through there, didn't it? Okay. And over here. Oh, no. Where's that? There's a little opening underneath there. Bring that around in there. And the area I really need to get to is right over here in the back where the resistor is. Hoping that perhaps if I get, maybe it's just dirt that's keeping things from flashing and all the other fun stuff from working properly. Okay, so that's that. Now we still have these switches to contend with. There's no real easy way of getting in there, is there? It's we can try from behind, like so. Feeling quite as stuck as it did. Okay, let's put some air to it and hopefully that'll do something. Who knows? Plugging her in, and so I got no flashy flash on the front panel here. Although this is flashing, and I don't quite think it's supposed to. I have a capacitor hooked up into the on here. Let's see if we can get anything to come up. Yeah, now the value is not doing anything. Oh boy. Yeah. So the value button now is not doing anything good. Okay, there's the leakage test. Maybe it just needs to clear up. Oh, okay. Yeah, maybe. So it could just be it needs to clear the, or it needs to dry up. Let's get this potentiometer here too while we're at it. The lead 0 potentiometer. And of course it's having no effect whatsoever. Surprise, surprise. You would think it would zero out the leads. Let me think a second. If, trying to remember if zeroing out the leads, maybe I had to have, oh, could be this. It could be I have to short them together. Ooh. Okay. And hold it down, perhaps. No. No. No, that's not doing anything. Oh well. It was a stab in the dark that maybe the leads needed to be clipped together and to zero it out. But that appears not to be the case. So 350. Leakage test. Starting high and coming down. Never quite settling. And we're at 10 volts. Let's go up to 25. It's taking its sweet ass time, that's for damn sure. Shouldn't take this long for the leakage test. Yeah. Nah, something's still amiss. Be a bad CMOS IC, or several of them. If you take a look at the service manual, it is not pretty. So here's display board, digital board. This is the display board. And the schematic for the display board. Parts list for the display board. Unfortunately, this manual has nothing to do with how to adjust anything. It's just strictly the PCB layout, which is good to have, of course, but in the main board layout, that's here. Zoom it down a little bit. Yeah. So yeah, the quite a lot to go through. I want to choose a certain area to look at. So I will be looking around a little bit for some voltages and get back to you with some results. Okay, so remember when I put this resistor in? This guy. I'll show you right here. So this was burned up, and put the new one in. The new one seems fine, except for if I turn on the power, and just the act of turning on the power, and if I touch that resistor, it is really hot. Not just warm hot, but finger singeing hot. And so that's strange because I'm not really sure why that is. And I'll look on the schematic. I'm gonna come down here to where this problem started. So if we look here on the switch where that resistor is attached, zoom right on in here. So there's the resistor R7, okay, and the diodes checked okay, so I'm still assuming that they're okay. Of course, there might be a problem there, but regardless. Okay, so now the little arrow says 2172. So what this is referring to is the other board, not this board that everything is pointing to, the 1000 board, but it's this other schematic up here. Okay, this board, which is what they refer to as the digital board, or, well, actually they're not really referring to it as anything, are they? But we assume it's the digital board because those are the foils for the digital board, and these are the components on the digital board. So everything on this has a 1 in front of it. So let's zoom in. If we go here, now it said 2172. So if we come over here, here is the switch that well, the output of that switch, 72, and it says OW2 SW2. So this is where it came off of, which was switch 2, and the little hexagonal figure in the 72. So then it comes over here into this little circuit, and the transistor, there's a diode and a Zener diode, so it's a cheap little regulator here for approximately 20 volts, looks like. And then they're just taking the collector current in, filtering it through this massively huge capacitor, which is this. Oh no, it's not there. Which is this capacitor here. In reality, it's 2200 microfarads, but they have 2000 printed here. Anyway, it's so it's this circuit. So I decided, well, let's take a look at it. And so if we go to the circuit, it's over here. Actually, it's kind of near that big filter cap. Here's the transistor. And, excuse me. So let's grab the transistor, shall we? Look at this. Look at this leg of the transistor. It is just kind of floating in the breeze over here. I would love to know why. So, now if we go underneath, take a look. You see those two open traces with no solder on them? Yeah, those are the two of the legs of that transistor. So apparently this just was never produced right. Let's zoom in on that. it never quite had enough solder on there. At least the best that I can tell, or was marginal at best. So, what to do? What to do? Well, focus would be nice. Yeah, so, well, on top it looks okay, but on bottom it sure as shit don't. And that leg over to the left there is definitely not happening. So, let's solder it in. Got lots of flux in there. Quite the little solder ball. It's okay. I'm gonna hit all the pins. This one pretty heavily too. Okay. Look underneath and see if what we can't see. Oh, we need to move you up. Okay. So there's the underside. It's not looking very good. Is it? No. So we need to attack from this side. How does that look? That's better. All right, we're gonna try it out. See if we can make some magic smoke come out here. All right, so we got 43. I wonder if no, this is coming to rest on its own. All right, let's move this dial around. And no flash except on the display. That's not supposed to happen. I'm getting the reading 12. Let's crank this up. Yeah. Alright, so this is not, leakage is not checking out. So the cap is rated at 400 volts. And it's still not happening. So let's see, is that resistor still getting hot? Yeah, it is. It's still pretty hot. I tend to wonder if that was enough to make the smaller resistor just fry out. If so, then I still have a problem. But the input for this on this resistor, this orange wire here, is actually coming off of a tap from the transformer. This AC transformer has a whole bunch of taps on it to correspond with the high voltage that you can run into a capacitor on the leakage test. So you see here, see how the dial goes up to 600 volts. Theoretically, you can get 600 volts out of this into a capacitor. Well, how can you do that? You know, this thing doesn't have a high voltage DC power supply in it, and it's utilizing those taps off of the transformer. The transformer does some serious stepping up and creates high voltage AC. So after that, what it's doing to create the DC is going through the two rectifier diodes that are there on the selector switch. So after that resistor, it all comes in through here onto this into transistor 111. Then that creates the 20 volts. Could be the capacitor, or when the resistors is off value. Might be the reason why it's getting hot. We'll look into that and see what it is, but let's see if we're getting 20 volts out of this transistor. So it's hard for you to see in there, I know. And even worse if my hand's blocking things, but okay, so I'm getting 19.7 volts on one pin, 23.3 on the other, and the input is 20. Okay, so that would probably be the emitter out, 20 volts. So it's actually functioning the way it's supposed to. Okay. You'd thunk that after fixing those loose connections, something would be working, but no. No, it's not. Okay, so let's do another test here. We have the fluke. I'm going to switch it to DC. The fluke is connected here. Here's the probes of the fluke across this capacitor, and the leads off of the checker coming from here. Now, with this dial, if we start off here, the very smallest leakage test, we should get, respectively, of course, the approximate voltage of what it's set for. The first one is 3 volts. So, you know, look at the meter, 0.5. Oh, now, when I pressed it again, now it's jumping around. It's and you get all zeros on the display when it's around 2 volts. Okay, so it's jumpy, but it's there. So we notch it up to 6 volts, and it's hitting around 6 volts. Okay, we go to 10 volts, and we hit it, and we're getting shit on the meter, about 0.5. That's interesting. So 15, and we're getting about 0.5. 25. Now it's jumping up again. It's around 20-ish volts. Not quite 25, but 20 something. 50. Now it should be blinking. It's not. Let's see, what do we get? And we get 0.564 again. So something's not right. On the 100, now this is blinking. It's not supposed to. So let's hit it. 43 volts. Yeah, 43 volts. Okay, now 200. It stopped blinking. And jumping all over the place. Hard to say what exactly that's supposed to be. We're going to set the range on the meter to manual so that the meter isn't jumping around like crazy. So yeah, 58 volts, you can see that. Well, yeah, 30, 50, 40, 30, 50, 40, whatever, jumping all over. All right, now we're on 300 volt setting. That's the maximum on this cap, but we're gonna try the other ones too. And it's doing about the same as the 200 volt did. 400 volts. Yeah, about the same. 500 volts. About the same-ish. And all the way up to 600 volts now. And it's not gonna blow the capacitor at all. We know that because, well, look, it's 30 something volts. Now we're getting we were getting a leakage test, and the leakage test is bouncing all over the place, of course. I'm sure it was probably doing that on these other settings as well. Yeah, just kind of jumpy, bounce all over. So the DC is jumping all over the place. But let's look at AC for just for shits and giggles. So we're on set to 400, and let's auto range it. And then AC, it's a little bit lower. Let's go back to 50. And yeah, so we're not really getting anything of significance in the AC mode, although it kicks up for a moment and then settles down. So there's obviously an AC component in this in here as well. You would think though that it should be pumping out DC. So something strange in this circuitry, that's for damn sure. Okay, so next morning, and I'm starting this with a different idea. Got to thinking about how long this thing had been sitting on the bench and how it hadn't been getting used, and these old mechanical switches, if this were an oscilloscope, I'd probably be seeing all sorts of noise and crap dancing all over the screen. And so I got to thinking that there's probably a hell of a lot of dirt and corrosion on this. I know I shot the spray in here before. This stuff precision cleaner. Not so sure how well that did, because I'm still having problems. So one way to verify it is right here at this point. This diode, there's two diodes here. Coming into the diode is right off of the switch. This is really the output of the switch assembly of all the wires from the voltage tap. So the idea here is I'm going to test the output of all these wires through the switch assembly before it hits the diode anyway, and then we'll see if we're getting good continuity through the switch. Clip lead on here, wiggle it on there really good to make sure you have a good connection. And then my idea is to go to the solder points here, and I should, upon rotating the switch, get I should get continuity, and I should be 0 ohms from wherever. I'm not sure which position the switch is going to be in to get any one of these particular ones, but whichever one is closest to 0 ohms. So we're going to come up to the schematic here, and we'll zoom out a little bit and position our camera to get a better shot of the schematic page, hopefully without any herringbones. And okay, so you can see over here, if I can get my handy screwdriver as a pointer device here. All right, so I need to come up a little bit. All right, up here, further here. Okay, see, here's the rotary switch, right? And there's the 2 diodes. These 2 diodes are what I just clipped onto, actually right there at the corner where it comes off of the wafer of the switch and into those 2 diodes. So I'm clipped right here at that point, and then you can see all the other transformer taps are coming off right off of the transformer here. See, coming up and around. So they hit that switch, and as you turn the dial, you get the various voltages, you know, from 3 volts up to 600 volts. And so the first thing I want to see is how well are we doing here. If we're not getting our 0 ohms from whichever tap, we go to the rotary switch, we should have 0 ohms on each one of those taps coming off of the switch. I suspect it's probably not going to be the case, so, but let's verify it. Alright, so we're connected over here. The red lead's on the back end of that diode. And I think up here is a big red wire, and we should get 0 ohms. Or no, we're not. Okay, so look how this is dancing around. I'm hitting the switch back and forth, and look at this. Why is it dancing like this? Let's try adjusting that. Okay, here we are. So let's get the jaws on here a little better. Tug it, maneuver it around. So we're getting, okay, now we're getting 0 ohms. Okay, so now we could be pretty much rest assured that we're getting 0 ohms through this connection. This is good onto the ass end of the diodes. And now what I'm doing is I'm grabbing the dial. Well, you can't see, man. I wish maybe I can position it without getting without getting the scope in the view. All right, so you're gonna have to trust me on this. I'm grabbing hold of the dial like so, just grabbing it and tugging on it. Reposition over here, and so look at this. Okay, so we're at 0 ohms. If I grab this and tug on it, look what happens. Jumping all over the place. This is merely for me maneuvering the front of that dial. I'm not turning it at all. I'm just pushing on it. Okay. Now if I turn one position over, okay, now I should find the other tap that should give me 0 ohms. And that doesn't appear to be it. And it's dancing all over the place. Look at this. And even though we're running through other taps of the transformer, it should be steady. It shouldn't be dancing like this. so let me get this. We're on the 500 volt setting, and so let's go down here. Maybe. Nope. Up here, perhaps. No. Yeah. So I think, after seeing the performance here, I mean, I've got a good connection on these taps, and I'm convinced it shouldn't be dead. So let's go back to the 600 volt and see if we can get a decent reading here. And so maybe what I'll do is I'll just turn the dial one position over, and I should be reading some kind of certain amount of ohms, 100 ohms or maybe whatever. Now I'm getting like down to 5.80. Okay, I'm at 80 something. Hard to tell from the glare. I'm sorry. See if I can reposition something. Get that glare out of here. Okay, so all right, so now I'm seeing 85, and I touch the dial, tap, tap, tap. Look at that, jumping all over the place. Just tapping the dial. And this is not good. So now I'm on the 400 volt dial setting. And again, I'm keeping the same amount of pressure here. This is jawed on very good. And look at this is dancing all over the place. So, yeah, this is not happening. I mean, it is happening. It's not supposed to happen, is what I should be saying here. So, yeah, Fungats is what I gotta say about this. All right. Last we left you had some switches that needed definite cleaning, and so I went out. I got my favorite libation, some Deoxit D5. Woohoo! Brand new package and everything. So let's see if we can figure out how to open it. And let's see. So, nice little swing out squirter here. Let's have at it, and hopefully this will take care of things. If this stuff would come out, that'd be nice. So far it's not really shooting out very well. Yeah, there we go. Okay, that's better. Swing this around to and fro. And yeah, it looks like it shot through to the other side pretty well. So I'm just gonna rocker this back and forth a few thousand times. Well, so here goes nothing. We're gonna plug it in, see if we can make some smoke come out. As soon as we find the plug. Where'd it go? There it is. Alright. Off or on? That's off. Okay. Alright. Plug is in. And you cannot see the LCD very well, but alright, we're gonna turn this around and see if we can at least get this flasher to flash, and nope, no flashy flash yet over here. This is not, that's not good. Yeah, there we go, that's better. So, alright, let's yeah, I don't understand why the display keeps flashing like this. It's not supposed to do that. Lead 0 control still doesn't seem to be doing anything. Well, hello there. So, at last we left, this thing was having all sorts of problems when trying to turn on the knob over here to the various voltage settings. I'd get a bunch of flashing zeros. Now, as you can see, I've got my LED fixed. The flashing LED, we'll get into that. And notice there's no more flashing digits here. So, what was the problem? Well, it had something to do with this flashing circuit. I'll show you in a moment. Let's tip it on its side. And so when we were last together, I had this can of deoxit and cleaned the whole gang of switches over here, which, you know, it did in fact clean them, but it didn't really fix the problem. Every time I rotated the knob and got to a position where the last 2 or 3 sometimes, it would just start flashing crazy on the digits. It's not supposed to do that. The only thing it's supposed to flash is that LED right there. So, first things first, I checked the LED, and guess what? Well, it was blown out. Okay, so why was it blown out? There is a reason. So you see here where you have this 68 ohm resistor over here, right? And this says Y over here. So if we follow this down over and over, Y comes up in here, and Y, if you can follow my hand here, the Y circuit is tied into this little push button assembly for leakage. And but apparently it must also just be tied into the display in general. And what was happening is they were actually connecting. So come over here, I'm going to show you. The black wire here is the cathode of the LED, and that's what was actually very tight, very barely touching that yellow wire, which is coming off the 68 ohm resistor. They were touching ever so slightly, and of course I've pulled them apart now, but since they were just barely touching, when I grabbed the control and would maneuver it back and forth or rotated it or whatever, it was making the display flash off and on intermittently and stuff, and it quite literally was driving me bonkers. Not completely out of the woods yet, so I want to show you the next thing. So let's put this down. Okay, so we gotta turn it on, and so now this is at 027. Why? I'm not completely sure yet, but I have my suspicions. So one thing I was able to figure out was that as this warms up, right, look at the digits, they're coming down, and this will eventually come down to 0. I had gone through, after it had warmed up for a bit, I went through the procedure of zeroing out the DMM, or the just the readout here, so that it was 0. And then I had noticed after I shut it off, turned it back on again, that it would start at a high number, sometimes 30 something, 40, whatever, and then settle down to 0. So as you can see, that's what's happening. It's coming down to 0. And here we are, we're at 1. And okay, so maybe it'll sit at 1, whatever. Oh no, there's 0. So something's failing as it as it cools off. Actually, I think something's failing, and then it warms up and then zeroes down. So not supposed to work like that. And so the other thing I discovered was that if I take some air, just some regular air, is that basically a pretty cool temperature. I don't have a can of freeze-it spray, but I do have this. So I was poking around, and I'll show you, if we zap the circuit board, just some cool air, right? All of a sudden, look at that. Starts to increase. So now, you should never have circuitry that if you just pump air on it is going to make or break the difference in a calibration setting. So I do know that it's up on top here, and I have a suspicion as to which the component is. Why? Because I've already done some checking, and I don't want to make you go through every painstaking detail as to where the problem is. I have my suspicions, so I'm gonna point it out. I may be wrong, but I think I'm right. So if we come over here, you see this capacitor? That sits right next to a voltage regulator. And what I noticed is that if I hit that capacitor with air, watch, here we go. Look at that. Okay, so now you might be thinking, well, hey, maybe it's the voltage regulator that's at fault. Well, it's possible. It is possible. But if I let this come down a little bit, and if I take my air gun and shoot just the backside of the regulator, it does move, but that's also could be because the air is flowing, bouncing off of that and hitting the capacitor. It seems more like if I really direct the flow onto the capacitor, it jumps pretty immediately. See that? See how much it jumped? Whereas if I direct the flow directly on the component, it doesn't jump quite so much. Let's go to the back side of the component, away from the capacitor a bit. So yeah, it is moving, but again, there's air flowing all over the circuit board as I do this. So I've got my suspicions. I think it's the capacitor. And if you want to see in the schematic where this is, hold on. Okay, so here is the schematic, and here's the little voltage regulator that is actually, it's a 4-pin regulator. It's an adjustable, but it's got 4 pins. Some of them were like this in the old days. Anyway, I'm not really going to go into the regulator so much right now. Here's C128. It's a 10 microfarad cap. This is a negative voltage regulator. If you notice, negative 7 volts here. Positive is tied to ground. So it's filtering out. It's basically just doing some filtering. But since it's a negative rail, you tie the positive to ground. Negative goes to the output of the capacitor, or of the regulator. And so that's where that comes into play. And so we're going to change this out. Now, if we take a look here, one other thing I want to show you about this circuit. Sorry for the zooming in. Okay, so, all right, so here's the circuitry of that C128 10 microfarad cap, this little bad boy right here. Now, one other thing about this circuit board is that it is a double layer. There's another set of traces on the other side, and if you notice, what I like to call this is a little crusty. It is, the way they designed this thing, not the best manufacturing process, let's say. You know, it's all through-hole components, and the vias are just, you know, just crusty. There's no other way of putting it. So what I want to avoid doing is attempting to solder through it, because I did that on another component before. It just wasn't working real well. It didn't want to flow the solder through there really well, and it just seemed like it could be more of a pain in the ass if I have to pull this whole circuit board out, which you can. It's connected through these two header connectors, but it's also attached to this front display, and it's a bit of a pain in the butt to pull this thing out. So what I'd rather do, I'm just gonna go up to this capacitor very quietly and snip the leads off of the cap. I'm just gonna go in there, snip it off, and replace it with a known good capacitor. Okay, so another thing I want to show you actually is, well, we've got this fancy little Rigel here. We want to see what's going on at this capacitor. So what I decided to do is hook up the scope probe. There it is. Let's zoom out, please. Thank you. And we're gonna connect up to this cap. Let's see exactly what the heck is going on. If we can get onto it without destroying anything. And come on over to the scope and see what's happening. Nothing yet. Okay, hold on. Okay, so let's come on over to the oscilloscope. So right now the waveform, and it's a so look here, it's 1.18 megahertz signal. It's actually quite a high frequency. So a little odd that it's such a high frequency and it's causing problems, but it is. So this may just be that frequency may have something to do with internal resonance of the IC. It's UA79MG, in case you want to punch in the number at home. So anyway, so let's take a look. I'm gonna hit the capacitor with the cold air, and I'm gonna show you what happens. I'm right on top of the cap. Here we go. So you can see, after applying the cold air, there's a big increase in the size of this waveform. And it's also registering here. And so now it's coming down, the digits are dropping, and so is the waveform. You can see it coming down a little bit at a time. So I suspect this capacitor is supposed to be filtering out this noise and help sending it down the circuit and get rid of, the noise. They put it directly very close to the component, to the regulator, so that might be part of the reason why they did that. Maybe because this regulator may produce a resonant frequency inside of it that needs to be filtered out. Hard to say exactly what the engineers were thinking of, but that could be, if we go to the product spec, it may just say that you have to have a filter cap immediately next to this thing. I wouldn't be surprised. Let's get to changing it. Well, maybe I can show you how. We get the phone back up in its cradle, and maybe we can show you that process. Okay, so here we are. We're at full zoom, and I'm going to change this out. First thing I want to do, get the old capacitor out. But I do want to have enough leads to work with, so actually the preferred method here might just be to go ahead and rip it, literally rip it out. Got one popped out, another one. Okay, so that's out. Here we are. There's a 10 at 25. So we want to shorten the leads as much as possible. We have a couple sticking up right here. I'm going to trim these down. Okay. You can see that. And the negative side is to my right. So I'm going to lay that here for a moment. And just go ahead and tin these a little bit. Shoot a little solder on there. Okay, that's on there. That's on to the positive. So we're going to hook up the oscilloscope. We have our ground lead. Just going to go here. There's our lead clip. And we're going to get the oscilloscope connected to the negative side of this capacitor because this is filtering out for negative. Okay. And it's off right now. I'm going to turn it on. And look at that. That is quite a big difference. We were getting, we were getting a very good deflection like this before on the scope connected to that, and now nothing. And we got all zeros on the digits. Nice flat line there. So yeah, if there is probably some sort of weird little resonant frequency going on inside that regulator, so you need the capacitor to filter that out, smooth it out, and there we have it. So just to verify, let's hit it up with the air again. So I'm going to get this on the cap. Right on there. Here's the scope. Blasting away really hard. The air on there. Hear it? Nothing. Nothing at all. Nothing. No waveform whatsoever. Well, lo and behold, it's a few days later, and I found the PDF for this IC, and sure enough, there it is in all its glory. I'm going to zoom in a little bit, and if you read the text, the bypass capacitors should be 2 microfarad on the input and 1 microfarad on the output, and should be either ceramic or solid tantalums, which have a good high frequency response. If the aluminums are used, then it should be a value of 10 microfarads or larger. So that's exactly what they used in the circuit. It was a 10 microfarad capacitor. So obviously there must be high frequency response being generated somewhere inside the device that needs to be pulled down to ground. So there you have it. Okay, so as I just demonstrated, it seems as though we found the problem with the digits coming up high when you turn it on and then settling down to 0 after a period of time. And also the lead 0 issue as well. This also seemed to fix it. And I used nothing but air to find it. Let's try this out. Turn it on. Oh, plug it in first. That would help. And turn it on, and wow, look at that. Let's get it. Set the lights in the way. There we are, all zeros. Now the other thing I want to check here is I was also having problems with the lead 0 function. Let's zoom out here a little bit. There we go. So I was having problems with zeroing the leads. There's a thing you do where you press in and turn the knob. So, okay, here's my lead. I'm just gonna lay it down, press value, and turn. Wow, look at this. I wasn't expecting this to work. It actually works. Holy shit. Look at that. So we can get it down to 0, where it's toggling 1 and 0 or something. Somewhere close to that anyway. Come on. Yeah, that's pretty close. A little more. There we are. Let go. All right. Hey, we might be cooking with fire now. So here it is. The LC-53 back together in one piece. And just want to show you real quick. Turn it on. Starts off at 0. That's a pretty good thing right there. So here's a cap. This here is a 2200 at 35. set it for 25 volts. We'll do the value test first. And okay, 2270. Not too far off the mark. And leakage starts high, goes in half, half again, half again. 70, 190. Yeah, so in this case, it was splitting it in half every time it took a reading. Of course, this display doesn't update immediately. It does take a couple seconds every time, and within that time, the amount of current draw is going down and down. So, yeah, this guy reads good. Of course, it's a much newer capacitor, so it should. Here's one I found, and it's a pretty old one. Not sure what it came from, but it's 10 mics at 450 volts. And it even has a lead broken off, so we can just clip around this. So, let's see what this does. Value 11.8. Considering its age, that's probably okay. And we're at 25 volts. Leakage immediately 0. Let's go to 100. 0. 200. And still 0. 300. Okay, so we're starting to take a little bit of current, but went to 0 pretty quickly. Let's go to 400. And we're starting off blinking, which means it's filling up. And okay, so it's at 400 volts. It's taking its little sweet ass time to come down. In fact, given the fact that it's only coming down in 20 or 10 increments here, I would say this could be a candidate for not being in such a healthy capacitor. Yeah, because it's rated for 450, and still it's coming down still. It's not going up, but it's sure taking its sweet ass time about it. So I would really have my doubts about using this at 450 volts. That's for certain. And this other one, this is also 10 microfarads. And that's the negative side here. So we're at, let's go to 300. Let's do the value. And 14, that's what it was reading before when I was doing tests on it. And leakage, well, at 300, coming down pretty quickly. So that's all right. That's fine. Even as crusty and old as it is looking, still seems to be okay. So, yeah, the meter, she's finally back to working. I wish I could show you an inductor. Unfortunately, I don't have one. I looked all over. I simply do not have any inductors, oddly enough. But then again, you know, the type of inductors this was designed to read are the wire wound type, or perhaps a ceramic type. But yeah, that's not this. I don't think it's going to read inductors that you would find on a laptop or surface mount device. Perhaps might be a problem with this. And so, we'll see if I ever end up working on old radios or whatever. This could come in handy, but it's only got 2 spots for inductors for scales, microhenries and millihenries. And then the rest of this is for flybacks and flyback transformers and yokes on old TVs. And I don't see myself working on TVs anytime soon, so that sort of that section of the dial is pretty much useless at this point. So anyway, still good for the capacitors though. I'm glad to have it working again. You know, putting a cap under a load is definitely a good way to measure how well it's doing. The ESR reading is also very good, but this has its strengths as well. So anyway, that's it. The old Sencore LC-53 back and running. So that's it for this video. And if you got to the end, then you should get a bonus, because I know this was long. Lot of stuff we went over in this, but hopefully you'll gain some knowledge of diagnosing circuitry and figuring things out for yourself. So anyway, this is Joe from I Repair Electronics, and go out there and fix something today.